Hello everyone, welcome back to my channel. My name is Piyush. This is video number 42 and this is gonna be the last video of the series CK 2024. Up till now, we have covered everything about Certified Kubernetes Administrator, all the fundamentals of Kubernetes, Docker, and all the prerequisites. And now that we have learned everything from the cluster perspective, from the Kubernetes perspective, maintenance, and so on, now it's time to do the hands-on with the help of a real-time project, right? And what project are we building in this one? So we will be hosting Docker Container Registry locally as a container on the Kubernetes, right? So this is what we'll be doing. We'll be implementing all the best practices. We'll be implementing TLS. We'll be implementing authentication, creating secrets, deployments, replicas, services, and many more things in this video. So it could be a long video. Have some patience, watch it till the end, and make sure you do the hands-on as well, right? In this video also, why we are doing this and why have I called it a real-time project, because using Docker Hub as the container registry is not one of the best practices, because it is a public repository, publicly available. Although Docker has an enterprise offering which provide you a self-hosted container registries, but this is similar to what we are doing, right? With the help of an open source tool which is called distribution. I'll walk you through it. And with the help of that, we'll be hosting a local Docker container registry, which will be used to store all the images, and we'll be making sure that our storage is persistent and it could survive the pod restart or any mishap that happens to the cluster, and all the best practices. Right. So without any further ado, let's start with this video. Oh, before that, the comment and like target of this video is 200 likes and 200 comments in the next 24 hours. And if you want to watch more projects like these on Kubernetes, so make sure you complete the target of 1000 likes in this video. As soon as 1000 likes is completed in this video, I will be bringing another project like this. Okay, so let's start with that. Okay, so here is the CNCF project that I was talking about. The name of the project is Distribution Registry, and it provides you highly scalable server-side application that stores your Docker images and let you distribute container images. So basically, it's a container registry that you can host on your own infrastructure, on your host data center, on premises, or even on cloud, right? And there are some alternatives to it like Docker Hub, which we already aware of, Quay.io, GitHub packages, and these all are the public alternatives of that. There are cloud alternatives such as AWS has Elastic Container Registry, ECR. Azure has Azure Container Registry, ACR. Google Cloud has GCR, Google Container Registry, and Artifact Registry. IBM Cloud also has a container registry, and so on, right? So there are a lot many options available if you go with the public cloud, or if you go with any of the public offerings of container registry. There are other important industry standards as well, such as there is Sona Type Nexus and JFrog Artifactory. These two are also one of the very popular industry standards for hosting your container images, right? So if we were to start the container registry locally, like as a container, what we do is we just run the Docker command, like Docker run command, and we just use the registry 2 as the image, and that should be it. But this is not something that has all the best practices. This is not something that you would want to use as your production workload, or even your dev workload, right? This is just for the testing purpose, right? Because it does not have a persistent storage, it does not support TLS, and many more things are missing. High availability, fault tolerance, and many things are missing, right? So what we'll be doing, we'll be using the same image and we'll be implementing that on Kubernetes. Okay, day 42 folder also has the step-by-step instruction. It has a lot more details because I want you to practice a little more from your side than what we are discussing in this video. So make sure you try to understand each and every line that's been written over here, because every line has a task for you, right? So make sure you go through it and implement that by yourself. Okay. And like almost everything will be implementing from this. Only few things are left that you can do. So let me log into my terminal window. Okay, so here is my control plane machine, and rest two are my worker machine, worker 1, worker 2. Okay, so I have my Kubernetes cluster ready. All the nodes are up and healthy. Okay, and I'm using 1.30 for that. That's good. Now, to host a container registry, we need a few more things, right? To get started with. So we need certificates, self-signed certificates, or if you have a domain that you own, you can use Let's Encrypt. But let's assume you don't have a domain yet and you want to implement that by yourself, okay? Locally without a domain. So we'll be using self-signed certificate for that, okay? So for that, what we'll be do is let's create a directory. I'm inside my day 42 folder. Let me create a directory and name it registry. Okay, inside registry, I'm gonna create another directory and call it certs, and one more directory, and I'm gonna call it auth. Okay, so I'll show you why I'm creating different directories and what goes inside those. Just wait for a second. Now I have to generate self-signed certificates, right? So I'm gonna run the OpenSSL command, and all the commands that I'm running, all the steps that I'm following, it will be there in the GitHub repository, day 42 folder, README file. So don't worry about it. Okay. So let me run this command, which is an open SSL command, and I'm sure it is visible on the screen now because a lot of you have complained that my camera is hiding most of the screen. So I have adjusted the frame now, and I hope this will be much better from now onwards. Okay, so what this is doing, I'm using OpenSSL to generate certificate key pair. Okay, so there'll be a tls.cert generated inside the certs folder, and there'll be tls.key generated inside the certs folder again. Okay, and the domain name that I'll be using, the local domain, is my-registry, right? So make sure you add that in CN, and if you have any alternate domain, then you can add that in subject alternate name, but I'm using just only one name, so that's what I'm going to add. Okay, so this will help you generate that certificate, self-signed certificate key, and certificate pair. So I'm going to hit enter, and this is, we have discussed this in detail in a couple of videos where we have discussed SSL, where we have discussed TLS in Kubernetes. So if you are not aware of that, go and watch those videos as well. Okay, I'm gonna hit enter. Okay, I might have missed a double quote over here, so let me enter it again. And if it is working fine, you will see a lot of these getting printed on the screen, so don't worry about it. It's working fine. So I'm gonna go inside the certs folder, and both the files have been generated. Okay, now let's go back and let's go to the next step. Now, whenever you'll be hosting, or you'll be creating a container registry, you would need some authentication, right? To log into the registry, username, password, right? So how would you generate that? So for that, we'll be using a tool called HT password. Okay, and basically we'll be running a container which will do the work for us. So I'm just gonna run this command. Okay, docker run entry point HT password, and which is based on the HTTPD image. Okay, this is the image that it will be using, and it will encrypt your username and password, right? And this is -b stands for there is a specific type of encryptions that it support. It does not support base 64. So this, it will be doing this -b encoding, and this is your username, this will be your password, and this command will store username and password in the encoded format in this file auth-ht password. So let me hit enter, and it will pull the HTTPD image, do that encoding, and it will update the file. So now if I go inside the auth folder, there'll be a file generated for me, and it's HT password. If I do a cat on this, you will see the password in the encrypted format. User name is same, my user, but the password will be in the encrypted format. All right. Now this is also done. Now let's go back. Now we have these two folders, and if I do a find over here, so you will see hierarchy something like this. Now let's go back, and we have created these two things. Now we have to create a secret so that we can mount the certificates, because we cannot directly copy the certificates from this to the pod, right? So we have to create a secret, and using that secret will be mounting it on the registry pod or deployment. Okay, so for that, okay, so I am inside my demo rec folder, and inside that there'll be a registry folder. Inside that there'll be certs folder. Okay, so I'm gonna run kubectl create secret TLS. Secret is of type TLS, so there is a Docker registry type secret, there is a plain text secret which is also opaque, and we have the TLS type secret. So this is what we are creating, and we're gonna name it certs hyphen secret. Okay, and then we have to pass cert. So cert will be there inside. Let's give the entire path to be inside home day 42. Oh no, it'll be inside home and demo. Okay, let's give the absolute path home Ubuntu. Not sure why it is not doing the tab completion, but that's fine. So the current directory that I'm in is home Ubuntu demo rec. So I have to pass the certificate value as home Ubuntu and then demo reg. And inside that, there'll be registry. Inside registry, there'll be certs. And inside certs, there'll be tls.crt. Okay. And this is the cert, and we have to similarly pass the key. So key is also the same path. It's just instead of tls.cert, it will be tls.key. Okay, and that's it. So I'm just gonna make sure that the path is correct. So let's do an ls on this path, and yeah, it's correct. And if I do tls.cert, so it's good. Okay, so I'm gonna run the command to create a secret now. Okay, it says secrets created. So if I do get secrets, so it created a secret name certs hyphen secret with the type as TLS. It's just been created, and you can do a describe on this as well. Describe secret certs hyphen secret. Okay, and it is showing the data as TLS cert and TLS key. This is what we needed. Okay, now this is done. Now we have to create a secret for authentication as well. Remember the file that we generated for st password. So we have to use that and create a secret for the authentication. Okay, so for that, I'm gonna use k create secret. Now the secret type will be generic. Okay, which will be like a plain secret with a username, password, and so on, right? So the type is generic, and let's give it a name auth secret. And now we'll be using a file. So from file is equal to uh okay, we don't need everything. I have copied it by mistake, sorry about that. So let me remove all this, and the file location will be home Ubuntu demo reg, and inside that we have registry, and then auth. Inside auth we have a file st password. Okay, this secret is also created. Let's just verify the path ls. Yeah, that's correct. Okay, so let's do a k get secrets. Okay, so we have a secret for TLS, we have a secret for authentication. We'll be creating one more secret for Docker registry, but I'm going to show you at the end. Otherwise, it will just confuse you for now. Okay, so let's move ahead, and let's apply the persistent volume and persistent volume claim, right? Because we will be using these things like persistent volumes to so that our pod, even if the pod restarts or even if a new pods get created, the data remains persistent. Our data inside the registry, our builds, our images that are stored inside the registry is not lost. Okay, so we have to make sure of that. So that's why we are using a persistent volume and a persistent volume claim to bind that persistent volume with the deployment. Okay, so let me see if I have my file over here. If it's not there, I'm gonna copy it from a different folder. So let's copy volume. Oops, copy volume to the previous directory. I'm gonna use cd hyphen for that, and I'm gonna go to cd hyphen so that I could go back to my previous directory. Okay, now if I do a vi on volume.yaml, so I have a persistent volume. Okay, name is registry hyphen pv, and it has a storage capacity of 1 GB. The access mode is read write once, and the host path is home Ubuntu repos. That means it will mount the host path, like the path on your machine from where you are running this, to the path inside the pod. So if you don't have this path, I guess the path is not there. So I'm going to just create it. Home Ubuntu. Oh, it's already there. I have created it already. So repos is already there. So let's go back. Let's do a vi. Okay, so this is the host path. Now we have to bind it to the persistent volume claim. So for that, we are using the similar metadata like registry pvc. Read write one should be same as pv, only then it will bind, and the storage should also be within what is the capacity of your persistent volume. So this is also 1 GB. It's fine. Now let's just apply this. I might have it already created, so let me delete the existing one. K delete PV registry PV, and then there'll be a PVC. So I'm just cleaning that up so that I could create a new one from scratch. Okay, I have to create the PVC first. Okay, and okay, so these have been deleted. Now I'm gonna just apply this volume.yaml. Okay, it says created k get PV, and it says bound, and if I do k get pvc, this is also showing status as bound. So this is now good. Now we have created the persistent volume. Now we'll be creating the registry deployment on which will be actually hosting the pod that serves the registry pod. Okay, so for that we have a deployment YAML. Okay, oops, let me go to line 1. Okay, so name is registry. It has two replicas, so that if one replica goes down, you have another replica, or if one node goes down, you have replica that is serving from a different node. Okay, and the image that we are using is registry 2.8.2. It is one of the latest images. The version 3 isn't still in beta, so I wanted to use something that is stable. That's what I've used. We have different volume mounts. So this repo volume will be the volume inside the pod or inside the container where the repositories will be stored. So var lib registry, and similarly there'll be a slash cert slash auth, because we are mounting these directories as the volumes, right? So these will also be loaded. The certification and authorization details will also be loaded inside the container. Now we have some environment variables. You must be thinking, from where did I get that, and how would you know that you have to add these environment variables, right? So this is all part of the ht password utility that we have used. If you go through the documentation of that tool, it is clearly mentioned to use these variables and the values of it, right? So I have just copied it from there, nothing that I've added from my side. Then we have volume. So the volume mounts that we have created, we have to provide the persistent volume claim. So because this repo volume will have the repos, and we have created a persistent volume claim for that. So we have now bounded that PVC to this pod. Okay. Then we have cert volume and auth volume. Now we are mounting secrets as the volume. Okay. So that's why we have used these. So mounting secret as the volume is one of the best practices. Instead of injecting it through an environment variable, or instead of directly injecting that inside the pod, right? So this is what we use. Mostly we actually mount that as the volume inside the pod. Okay, so this is my deployment YAML. Now I'm gonna do an apply. K apply hyphen f deploy.yaml. It says it's created. If I do k get pods, both the pods are running, and now we have to export these pods as a service. Okay, so I have a service.yaml over here which will expose the registry. So remember, when we discuss about deployments or pods and services, we discussed about how you can expose a deployment or a pod with the help of a service. So we do that with the help of selectors, labels and selectors. So there is a label inside deployment with the name app equal to registry, and we are using the same as selector inside the service, so that service would know which pods to be bounded or which deployment to take as the backend of this service. Okay, so we are bounding that on a node port 5000 and target port is 5000, right? So let me apply this. I have service y and it says created. If I do kget svc, it says docker registry service has been created, and this is the IP for that on port 5000. Now, if I do kget describe svc, because I want to make sure that it is exposed on the endpoints. Okay, so if I do the describe on that, it says endpoints are 192.168.189.94 5000, and there is one more. What are these endpoints? These are the endpoints of the backend ports. Okay, these endpoints are of the backend ports that have added as the backend. Okay, so if I do kget pods hyphen o wide, so these two ports that I have, these have the same IP 166 and 1 and 94, right? So now service is listening on port 5000, and all the requests will go from the service to one of these pods, okay, for load balancing. That's what it is doing now. Now the next part is we have created deployment, persistent volume claim, certificates, we have created the service. Now we have to export the registry name as the environment variable on the control plane node. So registry, okay, let me do this and export registry name equal to my registry. And I also need to check the IP of this. So I'm just going to copy the cluster IP of Docker registry, and I'm going to export this as the registry IP environment variable. Registry IP is equal to this. All right. Now, if you remember the video in which we have discussed about DNS and how you can use a local DNS server, so that's what I'm going to do. I'm going to add the entry of registry name and registry IP inside the etc host file on all the machines, right? So that it will resolve the IP to DNS from local, because the DNS that will be using my registry, it's not a domain that we are owning, right? But we have to somehow resolve that domain to this IP. Okay, and for that we have to add an entry in the etc host file. So what I'm gonna do is sudo, okay, let me copy this first. Okay, sudo vi etc hosts. Okay, and in the last line, make sure you take the backup of this file before you make any changes or any important file in the Linux machine, because the changes are irreversible, right? Yeah, and it should be my registry. Okay, and let's just save this. And if I am gonna do, because I'll just copy the last line from here and I'm gonna paste it to all the other machines as well, all the worker nodes. So let me do a sudo vi etc hosts, and I'm gonna replace this to this. Let me save the file. Okay, let's do that in the next worker node, sudo vi etc hosts. And I have added it. Oh, I have added an I by mistake over here. So let me delete this. Okay. Now this is also done. The next part is, let's try to do a Docker login from one of the nodes. Okay. So we should go with Docker login. Okay. My registry on port 5000. So it should resolve with this host name because we have added the local DNS entry. Now username was my user and password was my pass wd. Okay. Now, if you have followed the video till now, you will also see the error something like this, which says X509 certificate signed by unknown authority. Right? Remember the certificates that we have created. We have to make sure that our nodes and our Docker also trust those certificates, right? So for that, what we'll do is we have to make sure that nodes also trust the certificate. So the file that we have tls.crt, let me copy the content of it. It was inside registry certs. So let me do a cat on tls.crt. Okay, I'm gonna copy this. Okay, and I have to make sure that I add this file at this location. Cd user local share ca certificates. Okay, in all the nodes. So there'll be a file which I've created previously, so I'm just gonna delete it. So now I'm gonna create a new file sudo vm tls.crt, and I'll paste the content over here. Okay, let's save the file. And once you do that, you have to run a command to update the certificate. So sudo update CA certificates. Okay, you do that on all three nodes. Now it says zero added because I already had a file over there. So let me do a fresh installation on certificate, and it should be good now because it says if it has added 147, it might have taken it. Or let me do a cleanup. So let me just do a sudo remove this again. Let me do a sudo update fresh. Now it should show the 146 certs added. Earlier it was showing as 147. That means it has removed one. And now if I do sudo vi tls.cert, paste the content over here. Okay, and now run the certificate update again. It should show one certificate added. So just to be sure. Now let's go back to the other machine, user local share ca certificates. Okay, let me remove this and let me run sudo update ca certificates with the fresh option, hyphen fresh. Okay, and now let's create a new file tls.crt and save it. And now let's do an update on certificates again. Okay, one added, and on the last one. So cd user local share ca certificates sudo rm this. Let's do an update on certificate with hyphen fresh option. You wouldn't have to run fresh option because you did not have anything till now, right? So you should be good with just creating the file and running the update command. That should be it. I'm just doing an extra step because I was facing the issue on this particular step, and it was not clearly mentioned in the documentation. So I had to go through a lot of pain in troubleshooting, and after 3 days, finally, I was able to find the issue. So you don't have to do all those things. Now update and then run it without fresh now. All right, it's been done in all the nodes. Now let's try to run it again. Run the Docker login. It will still not work, but I'm just want to show you. Okay, it's still throwing the same error because now we have to also configure Docker to trust the self-signed certificate. Okay, so for that, we have to create a new directory inside all those machines. And the directory is this etc docker certs.d, and inside that your host name colon your port number. Okay, let's run this command in all the nodes. Okay, and then you have to copy the cert file again to this folder. So let's do a sudo copy. Where am I currently? Inside the same folder. I can take the file from here. Sudo copy tls.cert to this directory. Okay. So let me just run this command in all the machines. Okay, this is also done. Now, okay, now let's try to do the Docker login again. You don't have to do any restart after this. Just try to run Docker login. And now it says Docker login succeeded. So this message is what is showing that it has accepted the username password plus it has trusted the TLS self-sign certificates that you have used. Okay, so this is good. Now we have done it, we have completed it. Now it's time to test the changes. To test it, I'm gonna pull a sample image. Let's pull Docker Nginx. Okay, I already have that image locally. So let's do a tag on that image and let's try to push that image in our Docker registry. Okay, the registry that we have created. So I'm gonna tag it with this command docker tag. Okay, so docker tag nginx latest, the local image, and then my registry, like the registry details, and the repo. I'm gonna create a repo. If it's already there, I'm creating a new version v2. Okay, so it's been tagged. Now I just have to push it. So let's copy this and docker push to this. Okay, layer already exists because version v1 already I have pushed it earlier. So now it is just pushing the newer version details, the metadata of v2. Remember when we discussed the layered architecture of container, how it works? So this is what it is doing. The layer that already exists, it does not push that, it don't make that changes. It helps um, the layered architecture helps the processing, the pulling, pushing, building of image faster. Okay, so now it says it's pushed the image. Now how do we verify that? So we will have multiple docker pods running. Okay, so kubectl get pods, and let's exec in one of these pods. Okay, let's go inside this hyphen sh. Okay, inside that, remember we mounted that on a particular directory. So var lib registry, and inside that there is docker. Inside that there is another registry and v2. V2 is the API version, I believe, and then repositories. So here will be a repository. We have my nginx repository. Okay, that we have just pushed to, and inside that there'll be uploads. Inside that there'll be images. So we have two folders, one for each of the versions, or it could be anything, but let's see. Okay, it has data, it has all the other details. So our docker images are there inside these folders, these repositories. So let's do an exit. And now that we have a pull and push the image, now let's do one more thing. Let's do one more test. Let's create a pod and use this particular image to spin up the pod. Okay, so I should have a deployment YAML somewhere over here. CD and then docker reg, demo reg. Okay, inside that registry. Oh no. Okay, let me copy it from some other folder. It should be over here. Okay, here, new.yaml. Okay, I'm gonna create a new nginx pod. Okay, and let's pull the image of version v2 from our container registry with the name nginx pod, and I'm gonna use image pull secrets. So let's see what will happen if we don't use this image pull secrets. Okay. Okay, let me just copy it first before I make any changes. Copy new to new YAML backup. Okay. Now let's just remove this part which says image pull secrets. Okay. Let's try to apply this image. New.yaml. Okay, pod created, kget pods, and you will see an error image pull. If you want to do a describe on this, nginx-pod, you will see that it says failed to pull image. Okay, pull access denied, repository does not exist or may require authorization. Authorization failed, no basic auth credentials. That means the image stored in that registry is private and it requires a authentication. It requires the basic auth credential so that it will certify that you have access to that repository to pull the image, right? And we did not pass that credentials. So how do we pass this credential? We pass that credential with the help of secrets. So if I do, um, let me just revert the file back from new YAML backup to new YAML so that it will have those changes again. Okay, now it has the image pool secret and secret name is nginx secret. So now we have to create a secret. Remember, we created one secret of type generic for the to store the authentication details, one secret of type TLS for the TLS handshake. Now we have to create one more secret of type Docker registry. Okay, so that we can use that as the authentication inside the pod. Okay, so I'm gonna run the command of creating the secret. Let me clear the screen, and this is the command kubectl create secret. The type is Docker registry, name is nginx secret, Docker server is my registry on port 5000, username and password. Okay, so let's use that and let's apply the file again. Kubectl apply -f. Okay, let's force this because it won't let me change those field. Okay, configured oops, get pods. It still shows image pullback off. Why it should not show it now? So let's do a k describe on pod nginx-pod. Says blah 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 failed to pull and unpack. Okay, maybe we were using v1. Okay, let me change it to v2 as well. Okay, we did not push the v1 image. So let's do it now and let's apply the change again. Okay, it did not restart the pod. Let me just do a cleanup, k delete pod, and let me start this pod again. Okay, k apply -f. Don't need to force it now. K get pods. No, still it has some issues. K describe pod. Oh, it says blah blah. My registry v2 nginx TLS failed to verify certificate. Okay, and my nginx failed. Okay, let's view this YAML file, and this is okay. Image pool secret name was nginx secret. Let's verify that as well. Kget secrets was nginx secret. Okay, this is good. Now let's check the registry pod. But we were able to pull from the registry, so there shouldn't be an issue with the registry, but with this okay, let me check this. Okay, it was a very silly mistake. When I was pushing the image, I pushed the v1 version to it, and while pulling through the pod, I was pulling the v2 version because that v2 version does not exist in the Docker registry. So that is why it was throwing me error. Now, what I did, I have tagged the image again as version v2. I have pushed it again because it was not pushed earlier, and as soon as I did that, the pod automatically restart because now it was able to find the image in the remote repository. Earlier, I was getting this error which says failed to pull an unpack image. My registry failed to resolve reference, not found, and so on. So I tried to pull it manually using Docker pull command, and again I was seeing the same error. Earlier it was image up to date, but then I removed that image locally, and when I did the Docker pull again, you see I was again getting the same error, manifest unknown. So that means I had some issue with the image name or tag itself. So that's why I just checked everything, you know, like if the Docker pull image command is not working itself, so that means the image itself does not exist, because I have already done the Docker login. So authentication should not be an issue, right? So that's why that's how it is. And now nginx pod it is there. So if I can do get pod hyphen o wide, right? And if I can do a curl on this endpoint, I should show the Nginx web page, which is this one over here. Welcome to Nginx, the default web page. So yeah, that's it. Make sure you do the cleanup after everything is done. Okay, so thank you so much for watching the video. I'm sure this was really helpful, and I'm sure this would have met your expectation about the real-time project in Kubernetes. That includes the concept that we have learned so far. We have seen a lot of best practices as well in this. And in the task of day 42 folder, there'll be a few more important concepts that you should be aware of, and make sure you do the hands-on for those as well. So it's gonna be pretty different than what we have done so far. Yeah, that's it. Thank you so much for watching. I hope I will see you soon with the next video. I'm still deciding which series I should be working on the next, but wait for the announcement, and I will see you then. Thank you so much and have a good day. Happy learning.